Hey, welcome back to Halite 3 Deep Learning Series. And last time I said that I would run the training code and basically let it run for a couple of iterations and see how far and how good we get. And this is what I did. You can see basically our epsilons were somehow starting from 1.0 to what's the next biggest one? I think 0.6, no 0.8, 0.6, 0.5. Yeah, so we ran all of these, and let me just show you some of the logs, some games in between. Okay, here, this is the run. And it's good that I did this off camera because, so first off, okay, we have our network, about 400,000 parameters. We ran 200 games, which roughly netted us 376. Not roughly, it exactly gave us that many samples. The total reward is minus 42. And you see we train the epochs. We start with a loss of 1,400 and it goes down to 1,200. Our accuracy goes a little bit above 20, so 25% maybe, or 20-ish. Exactly 20 would be random because we have 5 choices, and if we just randomly pick one, we are supposed to be right 20% of the time. Then the next thing which makes me a bit curious is we now already have an average reward of 3 by taking still 80% random moves. I'm not sure if 20% moves by the model can make that big a difference, but there might just be a huge variance amongst the random samples as well. So maybe we should have printed our the variance or standard deviation as well. Okay, we run it. You can see the accuracy increases. Then we are minus 29 again. So this kind of speaks for, okay, maybe the variance is just pretty high. Now we are already at 50% accuracy. And you see also interesting is that the loss is like really bad. It's quite okay maybe, and then it's really bad again. So I need to think about why this might happen, but currently I just don't know. One thing I think for sure is in this epoch we were already taking only 60%-ish random moves, and the other 40% were predicted by the network. And if you think about it, of course the network will be right in the prediction that it made itself. Is maybe an argument, but maybe not. I have to think about this because of the way we distribute reward. Let me talk about this in a second. Anyway, I ran it for another one. Now we are at 28 reward and 60% accuracy. Then we had 0.46 reward, 70% accuracy, 70 reward. One thing you can definitely see, I guess, is that it's more or less going up. 70% reward, 86, 70%, 79, 80%. So yeah, and here I stopped it because I thought, okay, we are already 80% correct. Why is this? In this epoch, we were already somewhere at 0.1 epsilon, so only 10% random moves. And I guess what's happening here is that we have exactly the network creating the samples that it's then trying to predict. Again, our reward function should actually tell us if we are right or wrong, but it might just learn one path and then be really good. So what I did, I ran a neural network game with 10% random moves, and okay, this first one was an error, but here I ran it again. You can see most of the time it's collecting something, and here I restarted the loop to try a little bit things, and then I committed everything from the last episode. So what I actually want to try now is I want to change this file to always have the second bot be random, and And the first bot we will give some certain number of random moves. Let's say 0 for now. Let's see what our network does. So we have our bot that moves only according to the model and our bot that moves only according to the network. And the random bot won. Bam. Okay, that's not good. Let's look at a couple of things. So our bot decides to move somewhere. So you see it already learned some stuff. It learned, oh, stopping in the first position is not good because we know that this would be a done episode and the reward would be -1. So it learned that moving around is good and this one is the best move to make. Then it can't move. And then here it now learned, oh, I can get an immediate reward by walking back where I came from. It would be not good if I move in this direction. It could be good if I move in this direction, and it could be good if I move in this direction, but it's not good if I stop. Again. So, and then it is actually back to the home, and it decides to stand here, which is surprising because standing will give us a definite reward of -1. And it hasn't apparently learned this yet, so probably we need a lot more samples. Then it goes out again, it can't move, and then basically learned. Oh no, it doesn't even come back. So yeah, I'm not sure. Oh yeah, it can't move and then it goes back, hands this off, and then it's done. And if we run this episode again, I think it should do the same thing. A similar thing, something changed in between. Ah yeah, of course, since our random bot is also moving around, it changes our predictions slightly. How do we get a total reward of 40, but we have 100? 105. Maybe even more bugs, let's see. This should be 46, but apparently we collected 105. Let's try one more if we can reproduce this easily. This one is now 46, so this looks good. 36. Okay, I can see this. Ah, 30 minus. Okay, 119. 40. 46. 84. How? So something seems to be not correct. I wonder if the last move 9. No, this is just stand still. Okay, let's check it out. Let's just here we create login info shape ID current queue and move index something like this, and let's move this to the front. Okay, so now we definitely know. So this is maybe not defined. Let's just define it. Move index equals 4, and here move index equals index. No, good. That's defined. Okay, now we know which chip moves where. And then we can also here logging info reward chip ID rewards -1, something like this. Okay, we just log everything. Oh. Another thing you might notice, it takes super long to start this. This is because the TensorFlow import is so slow. I googled it, I couldn't find really how I can fix this. It may be that this happened when I upgraded to TensorFlow 2. I would have to try to see if I can downgrade and it still persists. But I think if this is going on, I will have to somehow maybe write like a small web server which serves my model or something, and then the Halite bots just query this web server. This will be much faster, because especially on these small games, where is it? It took me 16 minutes to run 200 games, and on average like 5 seconds per game, and like 4 of these 5 seconds is importing TensorFlow. So I don't know. Anyway, okay, this is one of the games where we say we have 105, but here it only says 40. So let's check how can this happen. Here we move somewhere. Here's no reward, no reward. Here's the reward. Why does it say 1? Hey, I already can't remember. Reward chip ID. Ah, yeah, okay, whatever. Here's 26. Here's 20. Interesting. Interesting. Where do the 105 come from? Here we should maybe I'm subtracting something too much. $36 seems to be correct. 61, 26, and 20. So here's already something off. Here's 36, became 26, because probably we paid 10 in fuel costs. Here is 27, here's 20, and that's it. Oh no, here's another 20. And the last move. And the last move is a 3. 0, 1, 2, 3. This would be the missing reward. If the last move brings us home, then we don't add a sample for this. So technically this one but here it says 4. This is the can't move. So we are missing out on a move, I guess. But we have this one, and we should have this one because we have a prediction for it. Okay. Nope. We want to have dons. If the last move moves to our base, I guess we are missing the correct reward. 40, this is okay. This is just missing the 6 because of reasons. 46. 61. So here we have a can't move. Turn 10. We have 20. -1, -1, 26. So -1, -1, 26. Yo. -1, -1, 20. -1, -1. This is not so good. So, okay, the game doesn't call us after the last move. If our last move actually went to the base, it was a good move, but we will never know. I actually set done -1 to true, because the last one is true, the last move. What we should do instead, yeah, okay, we can fix this by saying, it's very interesting. We can actually fix this by append the Q&Q action indices. For ship, I need to fix this somehow. So for, oh god. So what I would need to do here is to figure out if the ships are moving onto the shipyard in their next move. And if so, yeah, but I don't have a state. Let me think about this. Because this is the last move in turn 9, and in turn 10 we still get called. And then we have 9, 9, 8, 8, 9. So 9, 9, 8, 8. Rewards and dones. So this one is kind of wrong. If it's the last turn, I need to add a for every ship. Let's just try and see if we can fix this for each ship in the ships. Now I found a whole different issue. Anyway, we would need to add a done and a reward. Let me also store a ship to move. Ship ID to move, ship ID equals move. Cool. Move, ship to move, ship ID, f ship dot position plus move shipyard position else. So if we move onto the shipyard next turn, then we can say done append true and rewards append ship dot minus ship game. And then you can basically need to do this old cell. How do we get the cell? Game map ship dot position minus ship dot position dot height amount times 10% of this. False, and then we reward. This is super ugly. I have no idea how to fix this, but basically in the last step we position is tuple. Oh. Is there a class called position? Import this name. Position self xy. Cool. 129. Let's see if this 122.6. Oh yeah, I have to round this. Apart from this, it looks correct. Cool. This is much better. Positionals, training, no, where's the bot? Is this rounded somewhere? Round plus 0.5. Round plus 0.5. Okay. Now we have some logic at two parts of in the class, and I'm not sure if we have more ships, this might break. Because this will break for sure if we have more ships, because we insert all the moves for the ship here. Will it? I think we have to think about this once we enable more ships, because we should probably store all the information in a dictionary depending on ship ID, like which states did this ship have, where did it move, and what's the reward for it, which would be a good refactor for maybe the next episode. Anyway, one thing we can probably see from this already is our bot is better than random. We beat random about every time, but it is not yet super good. So I don't know, if random makes the same moves, we make the same, like we don't find the best possible situation in. Oh, we got owned. Anyway, this is good. Should we do this refactor immediately? Yeah, the next thing is this slow loading times. I wonder, it's probably better to try to downgrade to TensorFlow 1 point something and see if this changes. Although this might make me spend all day on configuring imports and stuff. Okay. if you look at this, the interesting part is without any randomness, we only have positive samples so far, while yeah, we get some positive samples here, but we also have a whole bunch of negative -8s where we just don't do anything. So we did learn something. Let's immediately refactor this. In the last 5 minutes of this episode. Because just check this out. If we don't import TensorFlow, so now I ran 2 random bots against each other and it immediately returns, and as soon as I start loading TensorFlow, it hangs. The problem with downgrading a library is that I need to throw away my current model, but maybe this is fine. Okay, maybe this is a bit shorter episode, or it's not that short, and we only did some more debugging of the ship. But I will try to fix this TensorFlow issue offline, because then we can just run much more experiments. We need more than just 200 games, I think, especially if we want to scale this up to different sizes and everything. Okay, see you next time.